Hello, teacher Carlos. We are going to talk about more of calculus. We are here again. I'm grateful to speak these topics, and I going to start with this. Thank you for the opportunity, and thank you for the class. I will learn more. I will understand more. By the way, well, so we need to start. First of all, what we'll cover? Well, the first is quick concept refresher, the topics that we see in class. We need to refresh our minds to understand more. And the problem one limit of a function, problem two, limit of infinity, and the conclusion for the final. This is what we are going to talk about. Well, first, two key ideas from this unit. We need to understand there is the limit of a function. Limit f of x equals L, x approaches to a. The value f of x gets arbitrarily close to x approaches not necessarily the value f or of a itself. Limit at infinity, we get the numbers infinity. That's interesting. Limit f of x equals to L. X approaches the infinite number. The steady state long-term value f of x settles toward as x grows without bound, often a horizontal asymptote. But both describe behavior, not just a number, which is exactly why the engineers and scientists rely on them to predict how a real system acts. Well, for my opinion, like I'm going to be an engineer, I need to know this because this problem maybe in some of part of my job I need to understand it. I need to maybe make it in a program because if I like to make a one game, I need to know some of these topics like physics. But well, that is another topic that is not talking about calculus. But we need to go to the next part. That is the problem one, limiter of a function. Application to electrical engineering, filter design. We need to start testing an analog filter circuit. We need to read the blue part. Well, la meta. Find limit of h of w, equals what? W approaches to 3. If the limit exists, the print error is just an algebraic gap, not a real instability. Well, an electronic engineer is testing an analog filter circuit. The voltage gain as a function of angular frequency W in rates is modeled by, we can see the formula, h of w equals w squared minus 9 divided by w minus 3. The design software reports a pi by 0 error at w equals 3 rads. Does the filter actually fail at that frequency, or is this only a mathematical artifact? Well, we need to try direct substitution. Direct. We like the direct, Plug W equals 3 directly into the original function. This is the original function. H of 3 equals 3 to the square minus 9 divided by 3 minus 3 equals 9 minus 9 divided by 0 equals 0 divided by 0. In the terminate form, it says under 0 but divided by 0 gives no information about the limit. Direct substitution cannot answer the question. We need an algebraic technique first. Not always we can do the direct substitution because this 0 by 0 make us a problem. So we need to do it by the long way. So we have to do it. Simplify algebraically, factor and cancel. First, recognize a difference of squares. W to the square minus 9 equals W minus 3, and for another under the parentheses W plus 3. For the second part, rewrite h of w with the factor numerator. H of w equals w minus 3, w plus 3 divided by w minus 3, comma, w equals, or no, 3. The third part, cancel the common factor, w minus 3, h of w equals w plus 3 for all w equals 3. Where is cancel allowed in a limit? W never equals 3. Actually equals 3, sorry. We only examine values arbitrarily close to it, so dividing out w minus 3 is valid. Evaluate the simplified limit. Note substitution works since w plus 3 is continuous everywhere. Limit of w approaches 3, h of w equals limit w approaches 3, w plus 3 equals 3 by plus 3 equals 6. It's easy, no? Numerical check approaching w equals 3 from both sides. And here's the table that we can see the values, and the under that we can see that is correct, is fine. The engineering interpretation, here's this part gives us an explanation to how helps me if I be an engineering. I can, like I said in the beginning, I can use this. This is a topic that I need to use in some of the things that I maybe have to learn, maybe I have to do tomorrow, maybe it could be. And I don't know, this works for me. And for the next problem 2, limit at infinity, application to bioprocessing journey bioreactor growth. Growing a culture in a bioreactor, we need to see it. We need to go to the blue part. Go. Find limit p of t equals what? T approaches to the number, infinite number. This is going to be interesting. This long-term value tells the engineer the reactor's true carrying capacity. A bioprocess engineer grows a bacterial culture in a controlled bioreactor used for insulin production. Centers track the population P of T in thousands of cells over time T hours. Here's the formula: P of T equals 8,000 T plus 400 divided by T plus 2. Nutrients and tank space are limited. If the process runs indefinitely, what is the maximum sustainable population the reactor can support? Where we are going to see. Identify the indeterminate form. As T grows without bound, both the numerator and the denominator grow without bound. As T approaches to infinite number, 8000 T plus 400 approaches infinity, and T plus 2 approaches to infinity equals infinity divided by infinity. We can just say infinity divided by infinity is equals 1. Both top and bottom reach toward infinity. What matters is the ratio between them. The technique divided every term by the highest power of t in the denominator. Here t1. This is interesting. We can just say infinity divided by infinity equals 1. Divide every term by t. Part 1. Start with the original function, like I said in the beginning of the problem. P of t equals 1000. Part 2. Divide every term top and bottom by t. The formula divided t divided t plus 2 divided by t. And simplify each term for the part t. P of t equals the formula divided 1 plus 2 divided t. This is the three part. We need divide every term by t. Take the limit as t approaches infinity. Here's the graphic. This is important. As t approaches infinity, the small fractions for 400 t divided t and 2t both shrink towards 0. Here's the formula that we need to take care. Lim p of t equals 8000 plus 0 divided 1 plus 0 equals 8000. P of t equals 8000. Like his part says 1000 cells equals 8 million. So the graphic here is more important. We can see the number if 0, where is the beginning, and it's go faster, and it's going well like this, no? But at the beginning, start faster. The 0, and the next point is 4000 at 2 hours, and it go a little bit longer, not faster than the beginning, but it's increasing a little bit. But it's in that way. Scientific interpretation. P of t has a horizontal asymptote at p equals 8000. Since the numeration and denominator are both degree 1, the limit equals the radio of their leading coefficients. No matter how long the process runs, the population stabilizes near 8 million cells. The bioreactor's carrying capacity limited by nutrients, oxygen, and tank space. This is important, no? I like this topic because 8 million cells, we can see in the graphic that in the beginning is faster, but the the pass to, it says no matter how long the process runs. That gives us always the 8 billion million cells. It's impressionant. Here's the bibliography. We are finishing these topics. I like it much. And thank you. For conclusion from me, like I said at the beginning, this is important to know. These topics help us to make maybe some problems that we need to do in the future, and this helps me to understand more the mathematics, the calculus, and and thank you. This is going to a good way. So thank you for the attention. If we have questions, we always we can always go to Google and give us an idea to understand it more. Thank you, teacher. I see you for the next